welcome everyone. I'm Rani, and today we're gonna discuss the different models of the universe, starting from Aristotle to Copernicus to Newton. So, don't think small because astronomy is for all. With this, let's go. It starts in 340 BC when Aristotle, a Greek philosopher, put forward two arguments for believing that the earth was round. The first one was the earth's shadow on the moon is always round, which would only be true if earth was spherical. The second argument was the apparent position of pole star as seen from Greece and in Egypt. The Greeks even had a third argument for saying that the earth was round. For why else does one see the sail of the ship come over the horizon first and later the hull? Aristotle thought that the earth was stationary and the sun, moon, planets, and stars moved around the earth in circular orbits. This idea of Aristotle was elaborated by Ptolemy in 200 AD into a complete cosmological model. A simpler model was, however, proposed in 1514 by a Polish priest Nicholas Copernicus. His idea was that the planets moved in circular orbits around the sun. Nearly a century passed before his idea was taken seriously. Then, two astronomers, the German Johannes Kepler and the Italian Galileo Galilei, started to publicly support the Copernican theory. When Galileo looked at Jupiter using his telescope, he found small moons orbiting it. This implied everything in the universe did not need to directly orbit the Earth. At the same time, Johannes Kepler had modified Copernican's theory, suggesting that the planets moved not in circles but in ellipses. But as far as Kepler was concerned, elliptical orbits were merely an ad hoc hypothesis, rather a repugnant one at that, because clearly ellipses are less perfect than circles. An explanation was provided only much later in 1687 when Sir Isaac Newton published his Philosophiae Naturalis Principia Mathematica, which is probably the single and most important work in the field of physical sciences. In it, Newton not only put forward the theory of how bodies move with space and time, but he also made the complicated mathematics which is required to analyze those motions. In addition, Newton postulated a law of universal gravitation. According to this law, each body in the universe is attracted to every other body in the universe by a force. This force was stronger the heavy and the closer the bodies were to each other. Soon Newton realized that according to his theory of gravity, stars should attract each other. So it seemed that they could not remain motionless. The answer is no. That's because every point can be regarded as the center. That is due to each point has infinite number of stars on each side of it. It is an interesting reflection that before the 20th century, no one had suggested that the universe was contracting or expanding. It was generally accepted that either the universe had existed forever in an unchanging state, or that it had been created at a finite time in the past. Even those who realized that according to the Newton's theory of gravity, the universe could not be static, did not think to suggest that the universe could be expanding. Instead, they attempted to modify the theory, saying that gravitational force could be repulsive at very large distances. However, we now believe that such an equilibrium could be unstable. For example, if stars got slightly nearer to each other, they will continue to fall towards each other as the attractive forces will dominate over the repulsive forces. On the other hand, if they move slightly away from each other, the repulsive forces will dominate over the attractive forces and they will continue to just fall further apart from each other. So, this type of thing is so unstable. And now, finally, in 1929, Edwin Hubble made a landmark observation. It was that the distant galaxies are moving away from us. In other words, the universe is expanding. This means at earlier times objects would had been closer together. In fact, it seems that there was a time about 10 to 20,000 million years ago when they were all exactly at the same place, when the density of the universe was infinite. This discovery finally brought the question of the beginning of the universe into the realm of science. Hubble's observation suggested that there was a time called the Big Bang, when the universe was infinitesimally small and infinitely dense. Under such conditions, all the laws of science and therefore all the abilities to predict the future would break down. Yes, one can imagine that God created the universe at literally any time in the past. On the other hand, if the universe is expanding, there can be physical reasons that why there had to be a beginning. However, the eventual goal of science is to provide a single theory that describes the whole universe. Today, scientists describe the universe in terms of two basic partial theories. Number one, the general theory of relativity, and number two, quantum mechanics. The general theory of relativity describes the force of gravity and the large scale structure of the universe. That is the structure on scales from a few miles to a million miles, the size of our observable universe. Quantum mechanics, on the other hand, deals with the phenomena of extremely small scales, like a millionth of an inch. One of the major endeavors of physics today is the search of a theory that will incorporate them both, which will be the quantum theory of gravity. Today, we still yearn to know that why we are here and where we came from. Humanity's deepest desire for knowledge is justification enough for a continuing quest. And our goal is nothing less than the description of the universe we live in.